Hello, and welcome back to another episode of The Human Side of AI. This is Flora from jamout.ai. And if you're a regular here, you know what today is. Today is a Monday episode that belongs to our AI hosts, so I'm going to keep this one short. This episode idea, though, came straight from our Club Jam community out of our sales meeting with our members this morning, who many of them are deep or finishing up and wrapping up the Claude sprint. And they asked this question: what is the actual difference between Claude Cowork and Claude Code? And should I be using both? So I heard you. I pulled the resources. I handed it off to our AI hosts, and they're about to do what they do. This is Cowork and Code, the full picture on Claude's two biggest tools. Let's dive in.
You know, using a standard AI chat, it's honestly a lot like asking a master chef to write down a recipe for you.
Right, yeah. You get the instructions, and they might be brilliant.
Exactly. But you still have to actually go into your kitchen, chop the onions, preheat the oven, and, cook the meal yourself.
Yeah, you're the one doing all the physical execution. It's just an advisory relationship. The intelligence is on the screen, but the friction of doing the work is still on your shoulders.
But, imagine if that chef didn't just hand you a piece of paper. Imagine if they literally walked right into your kitchen, opened your fridge, chopped the vegetables, turned on the stove, and cooked the entire meal perfectly while you just went to the living room to watch TV.
That is the perfect analogy for what we're talking about today.
Welcome to the deep dive. Today we're crossing a massive threshold in tech. We are essentially moving past the era of the traditional chatbot and fully entering the era of the execution layer.
And we are doing this by looking at two specific autonomous sibling agents from Anthropic that are basically changing how work gets done on your computer. So that's Claude Code and Claude Cowork.
Yeah, and we have a really fascinating stack of sources for you today to figure out how this actually works under the hood. We're pulling from an academic architecture breakdown from the Velo lab.
Which is super technical, but amazing.
Totally. Plus, a very sobering security analysis by General Analysis, an implementation guide from Low Code Agency. And we're even digging into a very revealing developer Reddit thread to see how people are actually using these tools in the wild.
Because we aren't just looking at the surface level here. We're going to explore how these systems actually think, why they're terrifying enterprise security teams, and honestly, how they are already cratering the stock prices of legacy software giants.
Right. And I was reading through that developer Reddit thread we pulled, and there's a massive misconception that I think we need to clear up right away.
Oh, about them being the same thing.
Exactly. A lot of people see these two new releases, Claude Code and Claude Cowork, and they just assume one is an upgraded version of the other, or they think they're competing products.
Yeah, the developers in that thread were trying to use them interchangeably and getting, incredibly frustrated.
Yeah, the confusion is everywhere.
To really grasp the impact of these tools, you have to understand the split. It's not a difference in the underlying intelligence. The foundation model is the exact same.
Okay.
The difference is entirely about the execution layer and the user interface. They're built for two completely different types of workers and workflows.
Let's break down that family tree so you know exactly what is sitting on your hard drive. So we have the original Claude AI, which is just the chat interface.
Right, the reasoning tool.
Yeah. You ask it a question in your browser, it types back, it doesn't touch your local files, but then you have Claude Code.
And Claude Code is a command line interface. It's a terminal tool built strictly for developers.
So it's deep in the weeds.
Exactly. It lives directly inside your code base. It reads your local files, modifies files across directories, runs scripts, executes tests. It's an engineering assistant that, requires you to know your way around a terminal just to even initialize it.
Okay, so that's the developer side. But on the other side of the family tree, we have the sibling, which is Claude Cowork.
Right.
And this is what you use if you never, ever want to look at a terminal screen. It's a desktop automation GUI, a graphical user interface designed for non-technical users.
Yeah, it organizes your local files, handles cross-application workflows, delegates tasks asynchronously.
So you just give it a natural language goal, review its proposed plan, click approve, and it figures out the steps while you go do something else.
Exactly. So if we connect this to the bigger picture,
yeah,
the difference is the blast radius and the trade-off between control and ease.
Right.
Claude Code gives developers precise, granular control over every terminal command. But Cowork abstracts all that execution away. You give up that granular control for extreme ease of use.
Okay, but let's unpack this. If these two tools share the exact same underlying brain, the same agentic architecture, how does that intelligence actually operate under the hood?
It's fascinating because it can't just be a standard chatbot script running on a loop.
Right. And I was looking at that academic paper from the Vila lab where they basically cracked open the source code of Claude Code to analyze the architecture. And they found a stat that honestly stopped me in my tracks.
The 1.6%.
Yes. Only about 1.6% of Claude Code's source code is actually AI decision logic.
Yeah, that 1.6% is the entirety of the reasoning engine. The other 98.4% of the code is operational infrastructure. It's the harness.
Wow.
The AI model itself, it never directly accesses your file system. It never directly runs a shell command or makes a network request.
I found the best way to visualize this is like a corporate hierarchy. So the AI model is the CEO sitting in a glass office.
Right.
The CEO doesn't go down to the loading dock to drive the forklift. They just issue commands through a highly structured protocol what the paper calls a too-loose block.
Exactly. And the harness, that 98.4% of infrastructure, is the COO. The COO actually goes down to the factory floor, checks if the action is safe, and physically pushes the buttons.
So the reasoning is completely decoupled from the execution.
Fully decoupled. And the engine driving this is a reactive architecture called the query loop.
Query loop. Okay.
Yeah, it's literally a continuous while loop. The agent gathers context from its environment, decides on an action by emitting one of those two-loose blocks, and then it just waits.
It pauses.
Yeah, it pauses to verify the results of that actions from the harness before it decides what to do next.
So it's not following like a pre-programmed script. There's no rigid decision tree where step A always leads to step B.
No, it relies entirely on the model's contextual judgment, turn by turn. It evaluates the live state of your computer.
But wait, if it's just a loop making its own judgments dynamically, what stops the CEO from ordering the COO to delete your entire company database because it misunderstood a prompt?
Well, that COO is operating under a strict deny first permission system. The Vila paper details 7 distinct permission modes built into the infrastructure.
Okay.
And the default posture across the board is deny first with human escalation. If the AI attempts to use a tool that triggers a deny rule, the system blocks it instantly.
Even if it's generally allowed to do other things.
Exactly. Unrecognized or sensitive actions aren't allowed silently. The query loop pauses and escalates the prompt to you, the human, for explicit cryptographic approval.
Okay, that makes sense. But a CEO can only hold so much information in their head at one time. If this loop is continuous, gathering context, taking action, getting results, reading hundreds of files eventually, wouldn't the agent forget what it's doing?
Yeah, the CEO's desk gets buried in paperwork.
Right, so wouldn't it hit its token limit?
Yes.
Yeah.
That brings us to the absolute binding constraint of this whole system, which is the context window. The context window, which Anthropic caps at up to 1 million tokens, is the bottleneck. Every single time that query loop runs, it has to feed the entire history of the task so far back into the stateless model.
To prevent that memory from overflowing and crashing your session, Anthropic engineered this 5-layer compaction pipeline that runs before every single model call.
It's brilliant engineering.
Yeah, I was reading through these layers, and the first 2 make total sense. Layer 1 is budget reduction. It just caps the size of individual tool outputs.
Right, so if a tool spits out a massive 50-page error log, this layer trims it down so one bloated output doesn't eat the whole context window.
Exactly. Then layer 2 is snip. This is just a temporal trim. It cuts out the older, less relevant segments of the conversation history.
Yeah.
But when the paper got to layer 3 microcompact and layer 4 context collapse, I got a little lost. How is microcompact different from just snipping away old text?
So microcompact doesn't delete text. It actually compresses it using the KV cache, the key value cache. Think of it like muscle memory for the AI. Instead of forcing the model to reread and reprocess paragraphs of text every single loop, microcompact takes the mathematical representation of that text that the model already computed.
Oh, wow.
It saves it in the cache and feeds that raw math back in. It saves a massive amount of token bandwidth because the model doesn't have to reevaluate the words.
That is brilliant. So what is context collapse then?
Context collapse happens when the sheer volume of turns in the conversation just gets too long. It basically creates a read time projection of the history.
The projection?
Yeah. Imagine taking a 50-page transcript and collapsing it just the chapter titles. The raw data is still saved securely on your hard drive, but the AI only sees those collapsed summary headers.
Until it specifically requests to zoom in on a past event.
Exactly.
Okay, so we've budgeted the output, snipped the old stuff, microcompacted the cache, and collapsed the view.
Yeah.
But there's a fifth layer, right? Autocompact. So if all else fails, the system triggers the model to generate a semantic summary of its own conversation history. It literally asks the AI to summarize itself.
Right.
Wait, isn't that having the AI summarize its own memory a massive risk for hallucinations? Like, if I told it a specific formatting constraint at 9 a.m. and it summarizes itself at 2 p.m., it might just drop that constraint.
Your concern is highly valid. Semantic compression is inherently lossy. The AI will inevitably drop nuances.
Right.
But Anthropic knows this, which is exactly why they structured the pipeline this way. Autocompact is the ultimate last resort. The system executes the earlier, cheaper, safer layers first to avoid relying on semantic compression unless it absolutely has to.
Okay, that makes sense. So now we know how this architecture thinks, acts, and remembers. But what happens when you point it at the real business world?
Oh, man.
Here's where it gets really interesting. Let's talk about the sales apocalypse.
Yes. So in January 2026, Anthropic released the first 11 official plugins for Claude Cowork.
And then 12 more in February. And the market just reacted violently.
Violently is the word.
Following that January release, Thomson Reuters stock plummeted 16%. RELX, the parent company of LexisNexis, plunged like 14%. The Jefferies Group literally dubbed it the Syspocalypse.
Wall Street panicked. And when you look at how these plugins function, you see exactly why. A Cowork plugin isn't just a dumb API key.
Right.
It bundles domain-specific skills, subagents, and MCP connectors.
MCP.
The Model Context Protocol. It's this open standard that allows the AI to dynamically query a database, understand what kind of information is inside, and autonomously write queries to pull what it needs.
It's like downloading a career onto your desktop. Let's look at the legal plugin as an example.
Yeah, that's a great one.
It doesn't just read PDFs. Through that MCP connector, it talks directly to enterprise storage like Box or Ignite. It pulls a contract, performs a clause-by-clause analysis against your company's negotiation playbook.
And uses a green, yellow, red flagging system to triage risk.
Yes. It checks vendor history, drafts templated responses. It basically acts as a junior legal associate sitting inside your machine.
And we're seeing the exact same paradigm shift across other industries. Like, there's a finance plugin that connects to Snowflake and Databricks.
Right.
You can build financial models, run variance analysis, generate pivot tables autonomously. There's a sales plugin for prospect research through ZoomInfo, a biology research plugin for genomics.
What's fascinating here is these foundation models are no longer just generic assistants waiting passively in a browser tab. Via these plugins, they're acting as specialized, autonomous workers.
They are competing directly with established multi-billion-dollar SaaS incumbents.
Because if you run a finance department, why pay huge licensing fees for a specific SaaS tool to do variance analysis when your AI desktop assistant can just do it across all your local files for a fraction of the cost?
Exactly. You are replacing rigid software subscriptions with fluid, dynamic agents.
Okay, but if Cowork is this powerful, if it's literally threatening enterprise SaaS incumbents, why isn't every Fortune 500 company deploying it immediately?
Because of the security chasm.
Right. And to be very clear to you listening, we are pulling this impartially directly from the General Analysis Security Report. We're just relaying the cybersecurity community's assessment here.
Yeah, and the report lays it out starkly. Claude Code, the developer tool, runs inside an OS-level sandbox. On Linux, it uses Bubble Wrap. On Mac OS, it uses Seatbelt.
Okay.
Its write access is strictly confined, and network egress is heavily mediated. But Claude Cowork is a different beast entirely.
Because of the computer use path.
Yes. Course code runs in a VM, but because it's designed to use your desktop apps, it can click, type, and read pixels on your most applications. Anthropic explicitly states there is no sandbox between Claude and what's on your screen.
I was trying to conceptualize this sandbox delta. It's like a physical building, right? Claude Code is an employee working in a windowless, secure room where everything is thoroughly searched by security.
Perfect analogy.
But Claude Cowork is like giving that same employee a master key card to walk around the entire office building, look over people's shoulders at their screens, and open any filing cabinet they want.
It has to have that access to do its job, but it completely shatters traditional isolation.
And then there's the audit log gap. So if Cowork does something wrong, like leaking private customer data or a financial model, how does a company trace it?
They don't.
Wait, really?
That is the catch. Claude Code on the enterprise plan has full, granular audit logs, but Anthropic explicitly states that Cowork activity is not captured in audit logs, the compliance API, or data exports.
So it's a black box to the IT department.
Completely, and that's why Anthropic themselves advise against using Cowork for regulated workloads like HiPAO or SOC2 because it's still in research preview.
So enterprises basically have to build their own custom control planes or just stick to Claude Code for bounded engineering tasks.
Exactly. They share the same brain, but exist in totally different regulatory realities.
Wow. Okay, we have covered some serious ground today. We started by exploring the split between code and Cowork. We cracked open the architecture to see the model CEO and the harness CEO.
Driven by that relentless query loop.
Right. We unpacked the 5-layer memory compaction pipeline, the suspocalypse driven by plugins, and that massive enterprise security reality check.
It's a lot to process.
It is. But before we wrap up, we want to leave you with one final cross-cutting thought to ponder. This comes from that same Vila Lab academic paper. They identified a phenomenon called the paradox of supervision.
Yeah, independent research shows developers in AI-assisted conditions actually scored 17% lower on code-based comprehension tests compared to those who didn't use AI.
A 17% lower understanding of their own code. Which brings us right back to our kitchen analogy at the very beginning. Having the master chef come in and cook the meal for you is amazing in the short term. The meal is delicious.
You didn't have to do any work.
But as we hand over this execution layer entirely to AI, as we let it organize our files, negotiate contracts, and write software architecture while we sleep, are we automating away our own fundamental understanding of how our work actually functions?
Right. If the chef leaves, do you even know how to turn on the stove anymore?
It's exactly. Something for you to ponder the next time you ask an agent to do your work for you. Thanks for taking this deep dive with us.